Hi students. So now we'll go over setting initial values in practice. So as you saw in the previous video, uh, it's important to avoid setting conflicting initial values. Okay. The system at right has an initial angular velocity set on both the rotational damper and the inertia. Since these are directly connected while the R port of the damper is fixed, it's not possible for these values to be set independently. This is clear. So they ask you on task 1 to open the block parameter of the rotational damper and navigate to the variable tab and uncheck the override box next to the rotational velocity here. Okay, so saying okay, good. What do I have here for curiosity? Okay, I have any beginning value of 10. Alright, so this is the first task. Quickly going for it. So because it has initial value of 10, initially the rotational speed angular velocity was 10, so it goes from 10 and goes down. So alright, let's see here. A common cause of initial value conflicts is setting value on both sides of a mechanism such as a gear or a lever. Common cause of initial value conflicts is setting values on both sides of a mechanism. You know that here and here of a gear, you could not have same initial value. Like if you have a system connected to the orange gear and the blue, so they don't have same speed, right? Because you have a gear ratio. For example, if two inertias are connected by a gear, their angular velocity and torque are coupled, so they are dependent of each other by the gear ratio, coupled by the gear ratio and 2 over n1, as per below, which we are familiar with. Okay? So here they ask us to add a gearbox, well, and a mechanical mechanism, but just I will go and add it directly. Alright, this is a gearbox symbol in MATLAB. Connect the S port of the gearbox, which represent the input shaft, to the existing inertia. Okay, and the O to the new inertia. Okay, so it seems like you need to add another new inertia to the system. Okay. So I'll be connecting here, and I'll add another inertia to the system. And this time I'll be adding the output. Set the gear ratio of the gearbox to 2. So it has a gear ratio of 2. Okay. And the inertia parameter of the new inertia to 0.05. Okay. To 0.05 kilogram meter square. And this makes sense, like here the S represents the input shaft. So assuming you have an input shaft connected to a gearbox, and the output shaft is connected to the second to N2. So N1 is connected to, so you have a shaft here, Let's say, what is my pen? I can write for you. Okay, so basically nothing than that. Okay, this is the input shaft. Let's say here you have shaft 1, so this will be connected to the S, and here you have a shaft 2, right? That's what they are saying. And the O port, which is the output shaft, connected to, so here is connected to an inertia, the input shaft connected to some inertia mass, and the output shaft is connected to another mass inertia, okay? Rotational, if you wish, mass inertia. Okay. Yes, so that's how they are connected together. So via a gearbox of ratio 2. Good. All right. This is the task. What is the next task now? Task 3. The gearbox fixes the ratio of the angular velocity speed of the two inertia blocks, of course, with a gear ratio of 2. So omega s is 2 times faster than omega o. Alright. If you run the model without modifying it, you will find that indeed the inertia connected to the S port of the gearbox spins at twice the speed of the inertia connected to the O port, which makes sense. So now, however, you will also find that the initial angular velocity for the original inertia block is less than 10 radian per second, even though the beginning value is set to 10 radian per second. See, beginning value is set to 10, but if you run it, they are telling you you will find it less than 10. This is because Simscape blocks often have one or more beginning value set to high priority by default. This usually helps the solver make good initial guesses for your system. Okay, so you have priority high or low. Let's see. In this case, however, the kinematic constraint from the gearbox means that the second inertia should not have an independently set starting value. So you will have to manually change the priority. Second inertia should not be having independently starting value. If you look to the starting value, he should not be independent, okay? Because here they are telling you beginning value is 0 and priority high. And here beginning value is 10 and priority high. So then it makes conflict. So how you want this to start at 0 and this is at 10? This is not possible. So what MATLAB doing is starting them at a 5, the value of 5. Which not what you want. You want to start at 10 actually. So what to do? Okay, let's see the task. On the inertia attached to the output shaft, change the priority to none. Okay. So let's change the priority here to none. Okay, so no priority in here. Notice that the override box is checked automatically. Okay, I didn't know. Override is checked automatically. Okay. Okay, that's what they said for now. Okay, so let's go for the next step. So here, when you said for the output shaft, rotational velocity has no priority. And here, the rotational velocity is 10. So my point is, does the following loop has the correct parameter setting? Okay, I'm putting them right. But the question is why still 5? Change the initial condition on the input inertia and verify that the initial value of the second inertia changes accordingly. Change the gear ratio of the gearbox and verify that the relation between the two inertia blocks is scaled properly. Okay, they are talking about changing the value initial condition of the input inertia. This is the input inertia. If I change its initial value, to 5, and then run the system. Okay. Yeah, that's what I was looking at, guys. This is now, it makes sense because it seems like I didn't run it before. Okay, so now maybe I can minimize this a bit. Okay, they said it's incorrect because of task 3, but now I'm looking for task for the when it is 10, okay? Which makes sense. That's what you should expect. When I run it, the beginning value is 10. Alright, because here it will override that. Okay, so basically that's what I want you to know, that you may have conflict in initial value. So then you put priority none for the one that it doesn't make sense, etc. Okay, maybe right. I want an initial value. You can change the gearbox as well. Okay, but changing the gearbox, here they are measuring actually only the input shaft. They are not measuring the output. You can measure it yourself if you wish. Good. That's it for this section.